One way to graph functions is by plotting points. And to plot points, we want to make an XY table. So we're going to plug in X values to the function and then do some work in order to get the Y values or the f of X values, the outputs. And we can cleverly choose the points that we plug in so that we get nice numbers, nice points to plot on the graph. So for example, with this equation, since the slope is 1.5x, this is going to be a linear equation. In order to get whole number points, we need to plug in even numbers for x. So we don't have to do this, it just gives nice points for the graph. So we could plug in -2 for x, and then we would do 1.5 times -2 minus 3. That would be -6. So the point -2, -6 is on this graph. We could also choose the point 0. That would be 1.5 times 0 minus 3. So y is -3. And the point 0, -3 lies on this graph. And then I'll also choose the point 2. 1.5 times 2 minus 3 is 0, so the point 2, 0 lies on the graph. Connecting these points, we get the graph of our function. Now let's draw the graph of the function f of x equals negative absolute value of x minus 2. In order to choose the points for this graph, we'll note that it's absolute value of x minus 2. So that means that we will definitely want the value x equals 2, which would be the center of the absolute value graph, or the vertex of the absolute value graph. And then we'll also want a couple points on either side. So we'll use the point x equals 2, and we'll also use a few points before, so 1 and 0, and then 3 and 4, and plug those into the equation. For plugging in 0, that would be negative absolute value of 0 minus 2, which is negative absolute value of -2. Absolute value of -2 is +2, and the negative out front makes that negative. So the point 0, -2 is on the graph. Plugging in 1, it's negative absolute value of 1 minus 2, negative absolute value of -1. So that is -1. Plugging in 2, negative absolute value of 2 minus 2 is negative absolute value of 0. Absolute value of 0 is 0, -0 is 0, so this is the point 2, 0. And continuing, negative absolute value of 3 minus 2 is negative absolute value of 1, so -1. Plugging in 4, negative absolute value of 4 minus 2 is negative absolute value of 2, which is -2. So 3, -1, and 4, -2. And we'll connect these points to get our graph. So an absolute value graph will always be shaped like a V, either like this, or as this example is, a V that shapes downwards. So that is just determined by whether we just have absolute value, or as in this example, if we have negative absolute value, then we'll have the graph pointing down. Example 3, graph the function f of x equals square root of x minus 1. We'll work this out the same way, where we have x and y values, and we'll do some work in the middle. Now, in order to plug into an absolute value or a square root graph, we need to make sure that we're looking at values in our domain. So values that are not in the domain for this function would be negative x values, because the square root of -2, for example, would give an imaginary number. So the first x value that we can start at is 0 for this function. And then, since we have a square root of x, we could plug in any other positive x values that we would like, but it would be more convenient to choose perfect squares so that we don't get decimals and we get nice points to plot our graph. So that means I would choose x equals 1, x equals 4, and x equals 9. You can choose other points and get decimals. This is just a little bit easier to plot by hand. So the work would be for x equals 0, square root of 0 minus 1, so just 0 minus 1, which is -1. Plugging in 1, square root of 1 minus 1 is 1 minus 1, so 0. So the point 1 comma 0 is on the graph. And then square root of 4 minus 1, plugging in 4, is 2 minus 1, which is 1. So the point 4 comma 1 is on this graph. Then plugging in 9, square root of 9 minus 1 is 3 minus 1, which is 2. So the point 9 comma 2 is on the graph. So a square root graph has this shape. So it is not necessary to choose these exact points, but being clever about the points that you choose can give you nicer points to plot your graph. You do, however, want to make sure that you're choosing x values in the domain in order to make the graph.